Hello and good day everyone. In the last video, I've shown you a method using Excel used to convert decimal values into binary using pick, mark, and subtract, especially involving integers. We have shied away from our traditional computation method, which is the continuous division process, because as I've said, it cannot be used to convert fractional values. In this video, I'm going to demonstrate how the pick, mark, and subtract process or method can be used to convert both integers and fractional values. The main difference in the process, however, is in the placement of the place values. Let's go right away to an example. In this example, we will be converting the value 436.547 from decimal into binary. So right away, we will do our we will construct our binary series by using by dividing the number 1 by 2 continuously. So we have the okay, you still lack column. We insert another column. So 256 is enough, and remember that uh, the next value in the series is 512. So therefore, it's already more than 436. We cannot use it anymore. So we'll have our decimal point here, okay? And then we'll make it a practice to convert only up to the sixth binary place, because the sixth binary place is sufficient already for people to represent very small values. Now, what is the 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 first place value when we go to the right? After the binary point, the first place value is zero point 0.5 or 1 half. We generate the place values again by continuously dividing the previous value by 2. So 1 half divided by 2 is 1/4. Okay, so we can indicate this as 1 half. This is 1/4. This is 1/8. We just equals this divided by 2. It's good that we can uh, show all the values. So this is 1 over 16. Okay. So 1248 going to the left, 1 over 6, 1 over 1 half, 1 over 1/4, 1 going to the right. So 1, 2, 3, 4. So this will be 1 over 32. Okay. And this will be divided by 2. So and this will be 1 over 64. Okay. So remember now, the main difference between fractions and whole numbers is the placement of the place values. Going to the right, we divide by 2. Going to the left, we multiply by 2. Okay. So we use the same table. We only take note of the position of the decimal point. So equals this times the place value, and we multiply. We copy rather. We copy this so that we can have the different place values, and then we sum. Oh, is there some? Because there's a vacant space here. We just delete that. Okay, that will be our decimal point. Okay, and then we will subtract the running total and we will mark this way. Okay, so for 436 we can pick 256. We are left with 180, so we can pick 128. We are left with 52, we cannot pick 64, we can pick 32. So after that, we can pick 16 because 20 is still bigger than 60. We have 4, we cannot pick 8 anymore because 8 is bigger. We can pick 4 though. When we pick 4, we are left with 1 half, 0.5437, which means that we cannot pick 2 because if you pick 2, it will become negative. Likewise, if you pick 1, it will also become negative. So therefore, it's useless to pick those which are greater. We have 0.5437, we can pick this. So we are left with 0.437, which means that we can pick, no, we can't pick 0.25 because if we pick this, this becomes negative. Therefore, we skip. We also cannot pick this because it will become negative. Can we pick this? No, we cannot pick this. Can we pick this? Yes. And can we pick this? Yes. That's already negative. So being the next, the, the sixth binary place, okay, we will omit. Okay, we will stop at this the sixth binary place, and we will now uh, mark the vacant spaces with zeros. Okay, so our equivalent is, okay, that's equal to, okay, let's copy this. Here's our answer, and we'll copy this. Or this will be our answer. This is the equivalent of 436. This is not exact, but uh, some more borders yet. It's not exact, but this is a close equivalent. Now, let's have a second example. Shall we say uh, 95.6124. This time we will use an exact value. Okay. So we have 95.6125. 95.6125. And then we will run our binary series. Okay. 32 still need 64. We just insert. And then we have the position of our binary point here. And then we will have 0.5 at the start. We just divide it by 2. 1, 2, 3, 4, and we just copy it. 1, 2, 3, 4, 5, 6. So we delete this, and then we just place the markers to indicate that they are actually a fractional part. Okay. So I hope we are able to convert this exactly. And then we are going to put the values, and we put the place values by doing an equals that times the mark, whatever mark we will have. We copy it there. And then we will delete this because it's a position of the decimal point. And then we'll sum. And then we subtract the sum, and we'll color the subtraction as red. So what's the next value that's lesser than 95? Obviously, that's 64. When we mark that, we're left with 31. When we're left with 31, it tells us that we cannot pick 32 because it's already bigger. We can pick 16. If you try to, if you attempt to mark 32, you will know that you have an error because the resulting difference is already negative. So we correct that. We mark 16, we're left with 15. So we mark 8, we're left with 7. We mark 4, we're left with 3. We mark 2, we're left with 1. We mark 1, we're left with zero point 0.6. Zero point 0.6 is bigger than zero point 0.5, so therefore we mark zero point 0.5. We're still okay because we're still positive. If you attempt to mark 0.25, that becomes negative, so anyway, you just correct. 0.125, that also becomes negative. So we go to 0.625, we're left with 0.025, with zero point 0.5. Can we mark this? Yes. And can we mark this? Yes. And that's how much we can convert. So this is now our final answer. So we copy this. 96.6125 is equal to this in value. Okay. So sometimes if you have an exact, for example, if you have a 625, let's try the 625 this time. Shall we say, let's make it small. 75.625. We illustrate the same point. So 1, 2, this times 2. We'll need 2 more. We have 64. We'll place it here. And then we just copy from our previous worksheet. We just copy the series because we know it's the same. We have our binary point here, and we'll copy from our previous. Just to make a long story short, and we insert the table, and we type the place values. Rather, we type the formula for the place to compute the actual quantity by multiplying the place values. Sorry, no. And then we sum. We remove this, and then we subtract the sum from the value we want to compute, and we mark this red. Okay. So now let's start our pick, mark, and subtract. The first pick is 64. The next pick is 8. If you try to attempt to pick 32, you're making a mistake because the red font becomes negative. So obviously we can pick 32 and 16, so we have to pick 8. We're left with 3, we can pick 2, we can pick 1. 0.625 is bigger than zero point 0.5, so we can pick this. 0.125 is smaller. If you attempt to pick this, it becomes negative. Then we have 0.125, so we now have an exact 0. So this is an example where we have an exact conversion from decimal to binary. We just copy this, place this here, and put the outside border of this. Our binary point is here. So sorry, we did not mark the vacant spaces. Okay, so this is the exact equivalent of 75.625. So you see, the pick, mark, and subtract process is very useful because we can use it to convert both integers and fractions. In the next video, I'm going to show you how to do subtraction by first converting the subtrahend into a representation called the 2's complement form. Thank you for watching, and bye for now.